This is a video of DC motor speed control using pulse width modulation. In this project, we vary the speed of DC motor using a variable resistor regulator like this. When we increase, decreasing, changing the. Now your speed is increasing and it is displayed on LCD with the help of ADC analog to digital converter, and this value is up to 255. Maximum value is 255, and this is the maximum speed of DC motor. Now we decrease with the tuner variable resistor like this, and speed of DC motor is decreasing and displayed on LCD 16:2 matrix, and speed is decreasing. This process is occurring with the help of pulse width modulation with the help of BT136 and IC MOC3021. This provides pulse width modulation, and this is a ADC analog to digital converter which takes an analog value and convert into digital value, which is displayed on LCD of matrix 16:2. And this is your DC motor. This is the working, how it can work, and these are the components: transformer, step down transformer. This is the input side. This is your output side. There are 2 wires on input side and 3 on output side. This is center tap step down transformer for value 12012. This is your AC. To convert it into DC, we use a rectifier circuit, full wave rectifier. These are diodes. This is the silver side is your negative and other side is your positive, and these 2 sides are common and given to a positive of capacitor, and side by side with a voltage regulator 7805. These are filtering capacitors. These 2 capacitors are filtering capacitors. One is 1000 microfarad and second is 470 microfarad. These are filtering capacitors, and this is your voltage regulator 7805. It provides 5 volt output, and across the output we use a LED across it to indicate your power is on. After that we use a microcontroller 8089S52. This is a reset circuit. This is reset switch, and this is a crystal oscillator circuit which provides clock pulse. This is a crystal oscillator, and these are ceramic capacitors. These are electrolytic capacitors, and these are ceramic capacitors. And this is your LCD 16:2 matrix. To convert analog to digital value, we use a ADC 0804. This is a variable resistor which provides a reference voltage, and this is your track circuit. This is VT136, and this is transistor 548, and this is IC MOC3021, which provides pulse width modulation, and it takes a value from input from this variable resistor called tuner, and output is displayed on LCD, or speed of DC motor is controlled. Now this is your sketch. To complete this project, these are the components, and this is your PCB, printed circuit board. This side is your component mounting side, and this is your soldering side. On whole side these are copper tracks, and this is your component mounting side. Now this is your transformer. Insert on this side. It has two windings. This is your primary, this is your secondary. It means this is your input side, gives 220 volt, or this is your output side. The output side, that these two black wires are connected across the positive terminal of capacitor, like this. One black wire is connected to this side, and second is your this side. And your red wire is connected to negative terminal of this circuit. It means on voltage regulator, this is input, center is ground, and this is your output. That means the red wire is connected to negative of voltage regulator. After that we use the diodes. These are the diodes. These are the diodes on which silver side is negative and other side is positive. The silver side, both of these silver sides are common and giving to common with positive of capacitor. This is your capacitor on which there are two sides. One is bigger and second is smaller. Bigger one is positive and smaller one is negative. Another method is there is symbol on negative side. This is your negative side. It means your positive is connected across the positive negative terminals of diodes. So we can insert capacitor on here C8, and D1, D2 are diodes IN4007, and in C8 your positive is connected across upper side and negative is your this side. This is a symbol for negative on this capacitor, this capacitor. C8 is 1000 microfarad, and on C5 connected a 470 microfarad capacitor. This is your 470 microfarad capacitor. The positive is on upper side and negative is on lower side. After that we use a resistor on R10, which is 470 ohm. The value of R10 is 470 ohm, and across it we use a LED light emitting diode. LED has two terminals, one is bigger and second is smaller. So bigger side is your positive and smaller one is your negative, and symbol is mentioned. Positive is across your resistor and negative is across negative. Now your power supply circuit is complete. This is your microcontroller circuit. Across C4 we use a capacitor of 10 microfarad, 15 volt. Positive is across upper side and negative is on your lower side, on which as symbol is marking. On this side we attach a micro switch push button, and this is this capacitor reset switch, and on R9 we use a resistance of 10 kilo ohm.